And let me introduce Dr. Hang Xu. Dr. Hang Xu is currently a data scientist at Google. And Dr. Hang Xu received his MA in economics and PhD in the Department of Civil and Environmental Engineering at Northwestern University under the supervision of Professor Pablo Durango Cohen. And his research interests include transportation infrastructure franchise, highway pricing, and road network analysis. Dr. Han Shu was born and raised in Anhui, China. Prior to joining Northwestern University, he received his bachelor's degree from Southeast University in Nanjing, China in 2014. This presentation is also based on his recent publication on transportation research about B. And I met Dr. Hang Xu when I was during my summer internship at Northwestern University. And so we are very pleased to invite Dr. Hang Xu to give us a talk about his PhD dissertation. Now let's give to Dr. Hang Xu. Thank you.
Thank you, Siwei. Let's get started. So the topic for this presentation is optimizing the procurement auction for public-private partnership in highway franchise. And so the main motivation of this research is due to the public funds shortage. So in the US, the majority of transportation infrastructure is funded by the HDF, and it has a big deficit recently. And I know recently, the President Biden is kind of like signing some reform bills on it, but yeah, I'm not the expert on politics, so there is still big deficit in this fund. So the government, basically, in short, the government does not have enough money to cover the construction of new road and also maintenance of a lot of existing road. So the government is seeking for private funds. But in exchange, the new built or rebuilt highway will be owned and operated by the private firm or private organization for a limited period. And after this time period, they will be usually, in most cases, it will be transferred back to the government, and it's known as the BOT, build, operate, transfer. We have a lot of common practices of this kind of public-private partnership in the highway. So since the government does not have the ownership of the road in the early period, so the government need to find a private partner and let the private partner to build and invest. Two main categories of this kind of transfer, partnership. One is from the auction of predetermined toll capacity. So that is saying the government will predetermine some production variables of the road, of the highway. So the two main one will be the tolling capacity. And then the firms, so basically the proposal, some design of the highways, high level design of the highway is determined by the government. And then the firms competing for the cost or revenue. So in short, it's pretty simple. One example will be minimum cost auction. That is, whoever asks for request for the lowest cost of building the road or request the minimum revenue for it will be the winner. And there are some variants of this kind of the baseline of minimum cost auction. One example would be A plus B bidding. A represent the cost in money, and B represent the cost in time. So that's basically two dimensions of the cost, but it's still the same thing. We also have least present value of revenue, LPV auction. It's quite similar, but it is meant to address the demand risk. Basically, if the firm is not able to recover the cost in the given time period, it will be automatically extended until the firm get enough money to recover their initial cost. So this is the part of the predetermined tolling capacity. Another category is competitive bidding. So that's quite different. The bidder will submit proposal and corresponding prices. So instead of the government, so basically the firms will determine the tolling capacity and all other production variables on their own, and they submit all this proposal to the government. The government then will select the best proposal price bundle. So kind of like when you go to a store and to take whatever product you want based on the product itself and the price. It is still the primary contracting methods in the United States. So these are two main categories of common practice for this highway franchise. However, they have some issues. So for the predetermined toll capacity auction, the government has to decide the toll capacity before finding its private partner. And the government, we can assume the government knows a lot about the people's needs, transportation needs, travel demand, but the government has limited information on the cost. So basically, the government has limited information on how much they want funds they need to invest in order to get the 2-lane road, and how much for the 4-lane road. But the private firm, which has a great expertise on it, they know this much better than the government. Another concern is the government is not able to adjust the decision according to the constitution of the private partners' characteristics. So for example, some private partners might be good at building the 2-lane road. Some are probably good at the 4-lane road. So they could have a different scale of economy, but
Dr. Hanshu, we have a quick question from Professor J. What's the definition of toll capacity? Yeah.
The toll capacity here is basically we assume it's a pretty simple model. The toll is how much they're gonna pay. Each of the traveler need to pay in order to get into the highway, and the capacity is measured in the vehicles per hour. So that's the maximum of the travel flow in the road.
Just the product of the maximum capacity of the facility and the toll that's being charged, assuming it's a common single toll. So simply the product of the highway capacity and the toll, right?
Yep. Yeah. But there are some details I'm gonna cover later. So
okay. Yeah. That's what I'm. Yeah. There may be a bunch of details there. So what the definition you are using, but right now it's at a general level.
I just want to set a general level and let it be as simple as possible, because we can easily extend it to some complicated model. And I will also cover some details about now I just consider this toll capacity, and actually there are other production variables. For example, how you collect your toll. You could build a ETC, and you could have some intelligent system like that. So it also maintaining its frequency is also another production variables. We could incorporate those, but it basically follow the same logic. So in this research, I just want to focus on these two simple ones.
So in the competitive bidding case, the firms can actually play with the capacity also.
Yeah, they can play with the capacity also, and all other things, because they are the owner of the road. So they are the designer, owner of the road. So they can make a lot of things. So that's why I said competitive bidding is kind of like built for the firms. The firms could optimize all the variables for themselves, and they know themselves much better than the government. So that's basically why we have some issues of this predetermined toll capacity auction. That also leads to another concern. So the government is unable to adjust it. Okay, so but for the competitive bidding, they also have some issues, because it's not the government as the main planner, it's the firm itself. So the firm want to optimize the firm's profit instead of the social welfare. So they have there are two directions. And this is the main concern. Another concern is it's a practical concern. It's not, because this competitive bidding sometimes is not transparent. The government is deciding to choose the proposal price bundle, and you have thousands of ways to justify your choice. So you can say the one you like, the government could justify some proposal by saying it's just kind of like they have their own preference over different plans. And so basically, it's not as simple as the predetermined toll capacity, because in the predetermined, it just costs. Whoever gives the lower cost will be the winner. So, and the main goal of this whole research is to address those issues. Address this issue by combining these two processes. We don't want to separate these two processes, because these two processes actually associated. You don't know, you cannot optimize your toll capacity without knowing who is the private partner, and you cannot try into competing without knowing the toll capacity choices. So in this research, I want to basically kind of combine this. The roadmap of this research is firstly to formulate the optimal benchmark for this combined problem. It's a theoretic, and it has some practical issues. And then we solve and analyze optimal solution. Then we incorporate the government's budget constraint as the practical concern, because the whole research is motivated by the government's lack of funding. So and then we provide some new ideas in the implementations of mechanism. And finally, we conclude and compare those mechanisms. Okay, so let's firstly jump into some basics. So in the first case, I want to talk about in the ideal world that everything is known to everyone, and we have this first best case, first best optimal. So here I will briefly go over this all these models and all these functions. So this SW referred to the social welfare or received from the highway, from the road, and this PN is the inverse demand function. Basically, it measures willingness to pay given N as the demand, number of traffic in the road. And notice here in this paper, I will kind of like focus on the static setting. So basically, there's no fluctuation on the demand, and there's no dynamics in the road. I just want to kind of like calculate the social welfare from the planning perspective. We can easily extend it to the dynamic setting, but it makes all the math more complicated. So here I just want to stick to the static setting. So we are doing the planning. So we just want to have expected demand, expected this inverse demand function. Okay, so C and K is the congestion function, and we can write as the function of the VC ratio N divided by K. N is the traffic in the road, and the K is the maximum capacity. So in theory, this number could go beyond N divided the VC ratio can go beyond 1, but it will make this C and K function a huge number. So this is and CI is the construction cost. And I define here with the cost efficiency indexed by I. So basically, different firms, let's assume I is the index by the firm. So that's saying different firms could have different construction costs. And this cost is also a function of a capacity K. And the capacity K, as I mentioned before, is measured in the vehicle per hour unit. So it's not like measured in number of lanes. Okay. Additionally, I write this construction cost as the sum of a fixed cost, C norm, and also a linear variable cost. Yeah, so this is the basic setting of the social welfare and all the costs on the road. Any question about this? Okay, so this is the first best optimal. It's pretty straightforward. Is subject to this market equilibrium. That is to say, the willingness to pay equals to the total cost. This toll is a toll in the road, and the CNK is the congestion function in the road. So basically, that's the total cost. This is cost in travel. This is cost in money. So that's a market equilibrium. We can basically solve this optimization problem easily if we know this C0 and CI. So we can, if we take this C0 as a constant, then we can write this optimal solution, tau star and k star as a function of CI. And it's pretty easy to verify this tau star is increasing with CI, but this k star is decreasing with CI. So that's to say, if you have a more efficient firm, can reduce the cost, then this tau will be lower because they don't need that much price to recover their cost, and also they will expand the capacity because their cost efficiency is high. The unit cost is low. Okay, so
a quick question for the unit of C.
Sure.
So the congestion function, the unit for it is time or money?
Oh, that's here. Yeah, this is a good question. So here is this unit of the CNK is actually in money, in dollar. We will have a conversion from the time to cost. So basically, this G kind of like it also contains a part kind of incorporates the value of time. So in this paper, we don't kind of like consider the like heterogeneity in the value of time. So we assume everybody has the same value of time.
Yes, understand. Thank you.
Okay. So yeah, because we are dealing with a planning phase, so we don't want to get into a lot of details into individual travelers. Yeah. So I just mentioned this first best optimum, but in the world we also have a private partner. It is not totally by the government. The private partner need to earn the money in order to participate in this kind of work. So we have also introduced the second best optimum. That is to say, the private highway will subject to the profitability constraint. So that is the only difference is that they add this profitability constraint. So that is to say, you have to guarantee that the private firm also also earns money from the road. The money, the profit is that N times tau is going to be the total revenue from the road, and CK is the total construction cost from the road. And one more thing I want to mention here is that we have some theories here that if the C0 here is 0, then this pi constraint is not binding. So that is say, you can simply remove it and get the same solutions before. But if we have some C0, if we have some upfront like fixed cost, then the firm is not able to recover their cost at the first best optimal. Those are some details, but this is also some big concerns in the practical of the public-private partnership. So we just talk about the first best and the second best optimal. However, there's one thing that's missing. That is information symmetry. That that is the main challenge of this research. So we assume that the government knows everything before, like in the first best and second best, the government knows this CI. So the government can solve this optimal solution, and they could decide the tau capacity. However, in the reality, the government does not know details about the construction function, the CI, and the C0. And we assume, in order to simplify the work, we assume the C0 is public information known to everyone. We can make it private, but the logic is the same. We only make math more complicated. And the setting is similar to other literature. So, and we also assume that the government has no information on CI except for the prior. The government basically know the prior distribution of CI. That is, the government could do some research and to know the range of the unit cost. So government actually have their own knowledge on it. And but the firm knows perfectly about their own CI. And we assume the CI is identical, independent, distributed among these I firms. So we have the information asymmetry. The firm knows their own CI, private information, but the government does not know. So the firms could choose to lie about their own private cost function. And by lying, they can gain some additional profit from the road because the government will make the subsidy based on the reported cost from the firms. So that's why we have some issues about information asymmetry. Without knowing this CI, the government is not able to optimize tolling capacity. Basically, what I mentioned before, they have to tolling capacity is a function of CI. And the government is also unable to select the best concessionaire because everybody could lie about it. And also the government is not able to determine and operate subsidy for the concessionaire to recover the profit loss because sometimes they could lie to get more subsidy for it. So in order to solve this information asymmetry issue, I wanted to kind of like design the mechanism and using that mechanism to kind of induce truthfully telling strategy, and then the government can use this truthfully reported value to optimize the objective. And in terms of the objective here, I want to mention the objective is slightly different from the one that I use in the first best optimal, the one I use we hope used in the second best optimal. Actually, the social wealth function is widely used in most of the highway franchise literature. But in this paper, I'm using a slightly different objective that is defined as public welfare. The reason is that in the social welfare function, if I can go back here. So social welfare function, here, this part is basically we can define this as the consumer surplus. So that's this PN is referred to the total unit utility that the user gained from the road. And NCNK is the total cost, like the total travel cost measured in dollar for the user. So the difference is difference. And we also have a part is a toll. So the government, so basically each of the traveler needs to pay for the toll as well as for the CNK as a congestion cost in the road, and they receive the PN. So this part minus NCNK minus N times toll will be the net benefit of this road to all the users. So what about this CCIK? This CCIK is not a burden for the government anymore, because the private firm will take over the construction and the private firm will also collect the toll from the road. So this part should not be in the government's objective. This part should be in the private firm's objective. And also here, the government need to remove the toll revenue from the objective function, because the toll revenue is collected by the private firm. By doing this, we will have this kind of form. So the public welfare is actually what the government want to optimize. That is the consumer surplus minus the transfer. M is a transfer to the private firm. So that's saying the private firm can do all the work, like collecting toll and also pay for the construction cost. But in exchange, the government needs to transfer amount of money to the private firm. The amount of money could be positive, could be negative, depending on the profitability of the road. So given that assumption, the government is actually optimizing this net between the consumer surplus and the transfer to the private firm. Okay, so in this paper, we'll optimize the public welfare instead of social welfare. Any question about this definition? Okay, so after
a quick question. So the social welfare is just the consumer surplus, and the public welfare is the
no, the social welfare is the sum of public welfare and the production surplus. The production surplus is pi plus m. Pi is the profit and m is the transfer. So basically, m is how much the private firm receive from the government, and pi is how much the private firms receive from the road. So the sum is the social welfare. Yeah, social welfare is the sum of how much surplus they can have from the users and also from the private partners. But in this setting, we don't need to consider the private partners' profit, because partners are making money from the road. Okay, so this is a slightly different setting.
Dr. Shu, I'm sorry to interject. Just to continue that line of thought, if the money goes to the private firm, that does come out into the society in some form. If they are publicly traded companies, for instance, or the people have share. I mean, that is that basically the difference between the social welfare and public welfare that you're talking about here?
Yeah, you're making a good point. So we can assume, so basically we can assume some money goes to the private firm will go back to society in some way. We can market this as, a lot of economists in Europe, they have a weighted sum of it. So basically they give the ratio. It ranging from 0 to 1, but never exceed 1. So basically, we cannot recover 100%. But sometimes we have a concern that the government who do this is local government, and the company could be from the foreign, it could be from foreign countries. Yeah. So and we can feel free to kind of put a constant here. We can put a constant here, like a ratio ranging from 0 to 1. But here I just want to highlight the difference. Yeah, and it's not making sense to make it 1. Yeah, it's not 100% covered. Yeah, so after discussing this objective, we will get to the general framework of to solve. We actually want to solve this information asymmetry. Okay, so the systematic way to do it is to apply it to the general mechanism framework. In the general mechanism framework, we have a message system. We have allocation system. We also have this awarding system. So basically the process of working this way. Each bidder, we have the mechanism, and each of the bidder will submit the message based on their own type. The CI in our setting, that's the unit cost CI, and the auctioneer, in this case, will be the government, will allocate the resource according to allocation rule. So basically, the government will decide the winner based on the message they receive from the bidders. And finally, bidder will receive the payment according to the awarding rule. So we have a lot of cases that the winner will get the money and everyone else gets 0. It's a typical case, but we also, in general, it could be any kind of function. And this allocated resource in our case will be to award the franchise. So in this research, we assume it's binary. It's either 0 or 1. You either receive the franchise of the road or not, and there's only one bidder will receive the franchise of the road. And by realization principle from Meissen long ago, it's we have a direct mechanism to generalize any kind of general mechanism. So basically, we can simplify this general mechanism into this 2 dimension of a Q and M. The Q is the resource allocation, quite similar as the pi. The difference is that in the direct mechanism, the auctioneer directly allocate resource based on the private type instead of the message. And also the bidder will receive the payment directly from their type instead of message. You may ask, what is the message? the message is just the type at all. So basically, it's a special case of letting this WICI equal to CI. And all this document mechanism is building on the assumption that each bidder will truthfully reporting their private type. But why the firm will report the type, I will kind of cover a little bit later on. So in this moment, we will have this theorem. So that is to say, any kind of this general mechanism, WPA, can be modeled by this direction mechanism, QM. And it has the same equilibrium and payoffs. Okay. So
Dr. Hanshu, a quick question for the type. So the type is the price for the project?
The type CI is the unit cost.
Oh, unit cost.
Yeah, it's a parameter of the construction cost. I just want to make it simple, make it linear, so that it's a unit cost, and we can make it as a parameter into a function in general. Yeah. Okay. So before talking to some details about this type of mechanism design, I would like to introduce 3 phases that we need to consider in this bidding. So first we have the ex ante phase. That is before everything. The firm want to decide if they want to participate in this kind of highway franchise. And the government want to decide about a lot of rules. So this is what called the ex ante phase. No information except that the prior is revealed. So that you can believe it's kind of you're playing a deck of cards. You don't know which card you're going to draw. You have no information on that, but you know the chance of getting each kind of card is the same. And in this phase, the government will evaluate the expectation of the payoff over the distribution of agent type. This is very important because the government does not know the agent's type, and the government does not even know which who can join this kind of auction. And this phase is played by the government. And we also have interim phase. So this phase is played by the agent. So it's kind of like each of the player of the cards will receive their own card, and they know their private card, and they know this information only by themselves. So they make decision on their own types. So they can make decision in the card game. They make decision if they want to stop or keep playing. And finally we have exposed phase. So that is everyone is revealing their own information, revealing their card, and the payment and decision are made according to the rules that is determined before this game. So we will kind of like discussing these 3 phases extensively when we get to the some incentive capacity instant constraints, and also to talk about the time capacity decisions. So we just talk about the general framework of this mechanism design. You will notice that the previous day I just mentioned that every mechanism can be modeled by the Q and M, but I cheated here. I also add 2 distinct variables, T and L. The reason is I want to incorporate a total capacity screening schedule here. So that is to say, to put it simple, I want the government to automatically to determine this towing capacity based on the private firm's reported type CI. So as I mentioned before, optimal tow and optimal capacity is a function of CI. So why not just incorporate them into this franchising the mechanism design? So if we incorporate them into mechanism, the whole process will work in this way. The government will publish the function, this QMTL. So like I was said, this is the ex ante phase. And then private firm will report, they will reveal their information and report the CI, and the government will decide the winner. So we also have the 4th step is that the winner will build the road based on the towing capacity schedule and receive the money based on the payment schedule. The difference is about the T and L schedule. So that is why I said that combine this tow capacity decision and the consortium selection, because this T and L will automatically adjust based on the firm's productivity. Okay, so in addition, the total capacity, the additional benefit is that the total capacity schedule will help distinguish the efficient firm from inefficient firm. Because if you are efficient firm, you want to optimize your capacity and total. So you will set, like what I mentioned before, if you are efficient, you will lower the cost. You'll lower the toll and increase the capacity. If you are inefficient, you want to increase the toll and lower the capacity. So the government can simply distinguish this by the proposal of, by the CI you give to them, and by the toll and capacity plan, the optimal to. So that's why I want to just, this is the benefit of this toll and capacity screening.
Dr. Xu, clarify question. So in your slide, you call schedule. What do you mean by the schedule?
Oh, schedule is basically a function. It's not a fixed constant. It's not a variable. It's a function. So that is say T is a function of CI, and for different CI, there will be a different toll.
So you mentioned if a firm is inefficient, it will increase the toll but decrease the capacity.
Yep. So that put it in a less confusion way. So that is to say, if a high efficient firm will have a higher, this T function is increasing. Actually, it is increasing with CI, and this L function is decreasing with CI. Yeah, that's why I mentioned the difference between efficient firm and inefficient firm. Yeah.
I see. So when we decrease the capacity, then the unit cost, the C subscript of I will increase.
It's other way around. We cannot. It's so if the firm has a higher CI, they will kind of like decrease the optimal capacity. As all I mentioned is optimal. You can feel free to choose any kind of capacity, but I'm just mentioning this to make it optimal. Yeah. Okay. So so that's all the setup for the mechanism, and now we want to address some concerns we have long ago, as to say why the firms want to truthfully report their type. So this is widely known as incentive compatibility. I want to skip all the on the tedious math, so I just want to highlight something. So basically, if we have any kind of screening mechanism, QMTL, we can write bidder's expected utility. So this is for the interim phase, like I was said, played by the agent. The agent will evaluate how much money they're going to receive if they report the CI tilde. But the true type is CI. So we will evaluate this UI function is the expected utility if they report CI tilde and the actual type is CI. And we have to guarantee that if they truthfully report their type, that is to report CI, that to say CI tilde equal to CI, then they will get the maximum from the expected utility. When we guarantee this constraint, we can guarantee that the firm will always truthfully report their type. And also we have the assumption that the firms are smart enough to make this optimization decision. So yeah, this is, and also we want to mention is that it's also given this estimation on the opponent types, because they have to evaluate the chance they get from the road. And in this paper, we assume it's totally Bayesian setting. And also we assume it's identical independent distributed for all the firms. We could have some complicated setting, like I said again, but I just want to make things simple and make this computation easier. Okay. So another constraint. So if we write this incentive compatibility into the function, we will have a theory. So that's this theory is the generalization of the payoff equivalence that's written in Mython's paper. So in Mython's paper, they have the general they have a payoff equivalence for one-dimensional and auction of private value auction. And here I generalize it a little bit to the tall and screening, tall capacity screening mechanism. So that we have this pi function that defined as a profit from the road, and for the private firms. So I won't skip some details about the algebras. But the main thing is that we want to define the GI function as the expected value of getting this franchise from the road, given conditional on others type. So this is quite important. From the difference from this and the previous slides is, in the previous slides we directly calculate we conditionally on the CI, C minus I, that is all other types. And here we calculate expectation and put it in the GI function, and we want write this GI function as so basically as the we can believe this is a gradient of this pi function. There are a lot of computational details about this, and feel free to check my paper for details. The main summary of this payoff equivalence is that we will write this S function that is only a function of CI. And this S function will be this actual function will have a relationship with a V function, and this V function is what we call is the surplus function for the private firm. So we can take VI as the expected payoff that the firm receive if their type is CI. So the difference from this UI is VI is the optimal solution for this UI. Like what I said, if a truthful reporting is to set CI tilde equal to CI, if we always enforce the CI tilde equal to CI, we will get VI. So we have to make sure two conditions. One is VI has to be, to put it simple, the derivative of VI is S function. And S function is derived from this complicated form. Another is the generalized monotonicity condition. This is also a generalization of the Mason's monotonicity comparison, monotonicity constraints. So basically, the only thing I want to mention is about some property of a GI function. I will explain a bit about these two functions. So don't worry if this slides scare you. So it encapsulates a lot of details. So yeah. Another constraint is individual rationality. So as what I mentioned, the VI function is actually we call ex ante payoff. That's actually how much you will get if your type is CI, regardless of others, regardless of whether or not you win, because this is expected payoff. So we have to make sure this payoff is greater than 0. So that is to say, before participating in this mechanism, we have to make sure the private firm has incentive to join. The expected payoff has to be greater or equal to 0. And also we have exposed utility. So this is the definition. So basically that's also encapsulated in the previous slide. So I don't want to get into details about that. We also have exposed the irrationality. So this is a stronger version of this one. So in this one, basically I mentioned is that expected payoff of joining this mechanism design, of joining this auction is positive, is non-negative. And here is the slightly different. Here is to say, so for any kind of opponents, I have to be winning. I have to be earning non-negative profit. So the difference here is expectation is positive. Here is under any circumstances, I have to have have non-negative payoff. So I would like to firstly enforce this weaker version of individual rationality, and then I can simply derive this version for the exposed individual rationality. Yeah. So let's put everything together. So I read a lot of things going on, but it's I don't want to go to a lot of algebra. So this is to explain this objective, we can It's basically like I said before. This CS is consumer surplus, and M is the payment to the firm. So the objective is for the government. The government want to maximize the the consumer surplus, net consumer surplus minus the payment to the firms. And we have this QI here. The QI is allocation, basically the chance of getting the firm I to win. So it's pretty easy to understand. So this is the EC is going to be the expectation of the net of the benefit from the road, from the public welfare perspective. And we have a lot of constraints I just mentioned before, but this one looks pretty familiar to you guys. This is the market equilibrium, and in the network, this is the user equilibrium. And VI here, this is the utility function I defined, and here, this two corresponds to the, if you recall, this one is the first condition for the generalized payoff equivalence. This is the second condition for the payoff equivalent. This is the monetary condition, and this one is the individual rationality. So basically, this is the previous slides, the individual rationality. And the last one is, yeah, so this is also hold for each of the bidders. Okay, so this this optimization problem is still very complicated because it is actually a optimal control problem, because we are not optimizing, notice we are not optimizing variable, we are optimizing functions. Well, optimizing function for to get the highest function, to get the highest expectations. So we want to have a simplification. There are a lot of derivation going on, so I just want to show the result. So the previous slides will jump into this form. We have the social welfare function. This one is someone we expect to see. And we'll also have the F over F function. This is called distortion. And we also have V-non. V-non is the minimal. Basically, V-non is the expected payoff that the low is the bad. I would say the worst firm will receive if the worst firm is the winner. So we can set it. You see, we have the optimization problem, and it goes into as a negative term. And we also have the constraint set it to greater or equal to 0. So you will see we can just set it to 0 to get the optimum value. It is true, but I just still want to keep it because sometimes they won't leave this V-non to greater than 0 in some circumstance. Also, we can feel free to set it to a fixed cost, to have a fixed amount, to guarantee that the worst firm still earns a guaranteed amount of money from the road. Yeah, so so V-non, we can just simply take it as constant. And I would like to explain what's inside this. Okay, so what is inside this is pretty straightforward. QI is the chance of winning for the firm I. So basically, what's inside is how much net benefit the firm could provide to the public. So this part will be the benefit, will be the surplus that the private can provide to the public welfare. Then we can make this as a function. Okay, so we write this as a virtual surplus function, R of CIT and L. So this function is a social welfare minus F over F times L. So the difference, so if you can recall, the difference is that in the information symmetric, in the ideal world of symmetric information, we don't have this F over FL. We don't have this term. But in the asymmetric case, we have this additional term. The only difference between symmetric word and asymmetric word is this distortion term. So that's what this simplification. Notice that previously we have very complicated design. Now we can boil this down to this distortion term. Okay.
Dr. Hampshire, can you clarify a little bit the term FCI over little f?
Oh, sure. Oh, sorry, I forgot to mention this. Sorry about that.
And times yeah. L is capacity.
Yeah, L is a schedule. Yeah, L is the capacity, is the capacity schedule. F is the, sorry, I really need to explain this. So this little f is the probability density of this distribution of CI. So if you recall, I defined this CI is IID, and the distribution of the CI is F. And F is a cumulative distribution function, the CDF of the CI. So basically, this part is the cumulative function divided by the density function.
Yeah, gotcha.
Yeah. So that's what I said. So if I said this, so you will say this F over F function is purely determined by the probability distribution of the CI. It is very important because think about it. If it's flat, then we will have one form of F over F. If it's kind of like a pretty concentrated on one point. So let's think about the one extreme case. If all the density is concentrated at one point, then it is the same as the symmetric case. Because we can almost for sure say that the CI equals to a constant. Then this number will go to 0. So that's why I said this F over F is very important. Okay. So we have this form. We want to get rid of this because this F over F is quite annoying. So we can get rid of by incorporate this into the SW function by have an imaginary unit cost. So previously we only have CI, and now we have a CI plus F over F, because this L is the capacity, and the constraint cost is the fixed cost plus the linear cost of a CI times L. We have a CI times L here. We also have F over F times L. Why not just put them together? So we will have imaginary unit cost of gamma. That is say we have exactly the same problem as before, but the only difference is previously we're dealing with the unit cost of CI. Now we're dealing with the imaginary cost of gamma I. And we have to make sure this gamma I CI is increasing. This is to conform, to comply with some property of all the complicated math I derived before. So, and we can have some property. We have some property of the gamma I. One of them is that no distortion at the pump. This is a very famous property in the Anycoff mechanism design research. But they say it's no distortion at top. We are dealing with the opposite because we're dealing with cost. Of course, you want to as low cost as possible. So why we see no distortion at the bottom? Because think about that. If CI is the lowest one, think about the cumulative distribution. The cumulative distribution of F will be 0. So that is to say, if you are the most efficient firm, if your cost is at the minimum of the boundary, then you don't have distortion at all. But if you are the most inefficient firm, you have to bend your gamma I by the CI. Okay, so that's said the torque is distorted upward, but the capacity is distorted downward. It is much easier to understand because F over F is always non-negative. That is say you incur additional cost to your unit cost. If you recall, I mentioned before, a couple of times before, that tau will increase with CI, but capacity will decrease with CI. So that's what I said, tau will be distorted upward and capacity will be distorted downward. Okay, so we just discussed about the difference between the symmetric and symmetric. It's almost the same. The only thing you need to pay attention is this this offset. If we put them together, this solution of the optimal mechanism design is as the following. We have a Q. Allocation is simple. We just take whoever gives the lowest CI, and we also have this schedule that is tau star. In the symmetric word, it's just tau star itself. But in the asymmetric word, we are having a tau star as a function of gamma I. So that is CI plus F over F. We also have this payment rule. This payment rule is actually derived from the 1, 2, and 3. I don't want to get into too much details. So the most important are 1, 2, and 3. So this is the solution for the optimal mechanism design. But we are missing one thing. One thing is that we keep talking about M. M is the payment. So here M is payment from the government to the firm. And as well as mentioned, the main motivation of this research is to solve the government short of funding. What if the government does not have enough money to pay, even not a slightly amount of money to pay to the government, to the private firm? So basically, we want to design a mechanism also to set some constraint on this end. So that motivates my analysis on the budget balanced mechanism design. So the only difference is that here we have enforced this exposed budget balance. I said exposed is that under any circumstances, the government does not need to pay anything. So you could have some cases that the firm are efficient. You could some cases the firm are inefficient, but I have to enforce that on any circumstance, it has to be less than 0. If it's less than 0, that is to say the government does not have to pay the transfer. Okay, so and I just want to briefly show the solution of it. The difference is that now we have we need to make it to the second best optimal solution, and also the payment will be slightly different. Okay, so I will briefly go to, I have another part of it, but given the time, I will briefly go over the rest of it really quick. So also I want to talk about the implementation of the mechanism. Like I was said before, the optimal mechanism design is pretty complicated. You have to submit truthfully report your type. That is say you have to report your private information about unit cost. Sometimes it's not efficient. So think about it in the case of you purchase, like you want to purchase food from McDonald's. In the direct mechanism, for all the things we described before, you have to tell the restaurant that how hungry or how unhungry you are, and then the restaurant will provide the quantity and ask for the payment according to how much hungry you have. So it's pretty. This whole work is pretty. This whole process is not unnecessary. We could have some cases like we have now. So that is the firm will, the government will kind of like publish some menu like this. Basically, this is amount, this is the quantity, and this is the price. This will be the ideal world, and the private firm will kind of decide the perfect the best bundle works for them. So I kind of like here I just introduced some scoring auction that is like already existing in literature. The main thing I want to highlight is the demand pricing. So basically follow the logic. I kind of like decouple this public welfare into two parts. As what I mentioned, the CS is the consumer surplus, M is the transfer. So we can write it down in this way. And by to decouple it to the part of the net benefit from the road and also the payment to the private firm. This decouples basically saying this part, notice this part is purely a function of N, purely a function of demand N, and this part is just a transfer. So basically that is to say, as long as the firms provide enough demand and ask for a reasonable price, the government don't care about the production details. The government don't care about the toll. The government don't care about capacity. The government don't care about the quality of the road. The government don't care about the maintenance frequency of the road, as long as they can provide enough demand in the road. So this is very important. So you'll say why? Because if the capacity is not good, if the quality of the road is not good, there won't be enough user in the road, because the user is they are subject to the demand, the PM function, the willingness to pay function. There will be a market equilibrium. If the toll is too high, there will not be enough demand into this highway as well. So basically, this market equilibrium can kind of perform like an invisible hand, kind of adjust this demand. Okay, so if we have this as the one of the important property, we can design a demand pricing mechanism. That is to say, the government can think about publish a contingent payment rule. That is to say, you ask for a price, but you have to give me the demand, like the McDonald's, like when you get to the McDonald's store, they have a bundle of a price and the quantity. In this case, it will be the demand and the price bundle. Then the private firm will decide to report their demand. Notice here is the report their demand. Basically, that's a demand proposal, and the government will select the concessionaire purely based on the demand choices. Ultimately, I won't go over some slides. So ultimately, we can simplify this mechanism into this way. There will be a YN function, that is Y is the payment, N is demand. YN function published by the government. And the firm will, based on the YN function, report their demand proposal. And the government will simply take whoever gives the highest demand. So it solves a lot of issues I mentioned before. Firstly, it's transparent because the government purely decide the winner based on the demand proposal. Also, it adjusts the towing capacity because there's no towing capacity here. The private firm optimizes the toll capacity on their own. Also, the government is able to optimize the social welfare because the YN function is published by the government by solving the public welfare function. So it solves all of these issues, but it comes with a little bit cost. So the cost is it still have a loss compared with the optimal mechanism design. But this loss is always less than the cost from a lot of common practices. So basically, the demand pricing is a good invention, but it is still not the optimal. I can simply show the comparison of the demand pricing. So on the left, we have a different the chart of the public welfare from different mechanisms, and this x-axis is number of bidders. So you will see if you have increasing number of bidders, this market will be more competitive. So there will be also increasing public welfare. And as you can see, the orange and blue are almost the same. The blue is optimal. The orange is demand purchase, demand pricing. But the green is no distortion. That is the competitive bidding. And the red is predetermined toll capacity. It's also a common practice of the auction. So these two are well below it. But you can see as the bidders goes up, the green no distortion is a conversion to the optimal mechanism, also demand purchase. So that is to say, this whole study works perfectly in the low number of bidder case. So if you have enough number of bidders, your market is enough competitive, there's no need to have this complicated design of screening because they have to competing for a lower price. So there is no way for them to extract enough information rent. But if not, if they won't have a few bidders, like 2 to 3, then they are extracting a lot of information rent from the government. They are taking a lot of money from the people, basically, the private firm. Okay, so yeah, that's basically all for this research. Sorry, I didn't kind of like paste it well, so I skipped a lot of details about that. So feel free to ask the question for the part that I'm skipping. Also, feel free to ask questions that you are interested in.
Thank you, Dr. Hangshu. Thank you so much.
Hi, Hong. How are you?
Hi, Michael. Long time to see you.
Good to see you.
Yeah, good to see you.
It was a nice surprise to see you were giving a seminar. I didn't know where you were, and I didn't know. I even forgot what your dissertation was based on. So it was really good to hear from you. Although I apologize, I wasn't here for the beginning. I had some errands to run.
No problem with that.
Any questions from the audience? You just unmute yourself or type in the chat box.
Yeah, any kind of question. So questions that I covered, and also the question that I didn't cover.
I have
No
a quick
questions. I asked the questions earlier during the talk. I just wanted to say, Dr. Shu, this is a very nice talk. I think you're not getting questions because they were kind of all just kind of fascinated at the type of analysis. I don't think any of our PhD students at this time are working on similar topics, even though UCI traditionally has always been a place with a lot of transportation economics research going on, starting with Ken Small and the names that you are referring to. But I think currently there aren't too many PhD students working on transportation investment and economics topics. So I think this was probably a very good sort of introduction and refresher for a lot of them to think about these kind of problems. So I think it looks like a really comprehensive PhD work where you have looked at all sides of the problem, right? So just wanted to comment on that.
Okay, thanks. Yeah, yeah. I just want to give a kind of like give a very high level preview of this kind of work. It is very interesting. So I really like this kind of work. I didn't dive deep enough to see more, but even go through it from the surface, I really benefit a lot from. So the main, I don't know if I make it clear, this whole research is basically, we are dealing with the case that one part of the kind of like a principal agent problem. One part of one part is kind of the principal want the agent to do some work for the principal, but principal does not know some detailed information. Kind of like you want to purchase a second-hand car, and you don't know, you go to dealership and you don't know about the car, and you don't know how some detailed information about the car, but you have to purchase it, make a decision. And how do you make a decision? You can hire someone to do it for you, but you two have a different incentives. You want to make the best of a car, and they want to make the best money from you. So basically, this is the kind of work like this. And it is slightly complicated than the car dealership case, because you need to consider some production variables like towing capacity. Sometimes they don't lie to you about the costs, like in the car dealership, they could lie about the price and they make the money from it. Let's assume they don't lie about the money, but they can lie to you about some production variables, like they ask you to buy the car with high speed, but you don't actually need it.
Yeah.
So they could, and they could lie about the capacity, like you need a 5-seat car or 7-seat car. Actually, you don't need it, but they can advertise it, and they encourage you to do it. And they encourage you to do it because they can make most money of it, and you don't know about it. So basically, this work is to reduce this information gap, is to net the agent to speak truth. But like I was said, if you ask them to speak truth, it always comes with a cost. And this cost is the distortion I mentioned again and again. So it's not optimal. You have to pay additional costs. That's why I said this delta, if you recall, this delta is, this F of F is always positive, because you have to pay additional information cost in order to reveal the information. So that's quite that's I think it's a high level summary of this work. Yeah.
Is this I mean any of your results being used out there in practice, or do you see it actually being used by government agencies?
I don't think it's because I think it's a new paper, and I don't think it will be used that soon. So hopefully it will be. Yeah, but yeah. So I think it has some practical benefits, like it's very transparent.
Yeah,
it's just kind of whoever gives the demand. We don't have to compare different proposals. Because towing capacity comparison is quite subjective. Everybody could come with their own social welfare function, and they can say this toll and this capacity is the best, and actually they just insider of it. So but here in this case, just whoever gives the high demand, and also it can reduce the information gap. Yeah, so if I'm the firm, I don't have to worry too much about my proposal. There's a huge bidding cost for the private firm. Yeah. They have to prepare a lot, but in this case, all the schedule is published by the government, and the only thing the firm want to do is say which demand level I want to target. Yeah, so it kind of like it saves a lot of work from both sides. So,
well, I mean, if there is a way to distill the ideas down without math, but more from the project selection, jargon standpoint, yeah. If you could just write a small monograph or something of that sort, and actually, take it to government agencies, or propose it, or write some, magazine articles, not journal papers. It might actually, go towards, because I think it's a very, very relevant, set of topics, and it's really, it should be out there in terms of, okay, here's a better way to do your project planning and project selection at the state level and the national level, right? I think it should be pushed, is what I would say. And I think we academics tend to just kind of stay away and write our papers, and nothing happens, right? Yeah. So maybe your advice, maybe Pablo will go around pushing these kind of things. Is anybody continuing to work on this with him?
Yeah, I think Pablo will continue working on this, but I think his current focus is not this one, but I think he will pick it up later. Yeah.
Yeah, I think it's important. I mean, these. I mean, there is significant public investment and public, economy implications in these kind of things. Because look, I mean, Biden is bringing out what, 150 billion or some, some big numbers that are coming out. There'll be a lot of projects, So doing those things in a better way, and also understanding the fact that a lot more information is available. Information is becoming available. So real-time monitoring and testing of expenses by the companies. Some of the information that they don't bring out can still be observed now.
Yeah, I've been reading a few things recently that, I mean, obviously there's the Biden administration's proposal of, they're just throwing a bunch of money at states and then have to decide based on the legislation roughly what they're going to deliver. But I saw something recently that like the construction industry in the US, and particularly infrastructure construction, has actually decreased productivity over the past 40 or 50 years. Basically, we've gotten worse at delivering infrastructure projects than we did 40 or 50 years ago, which is just like a staggering result compared to the level of productivity increases in the other elements of the economy. Yeah. And I mean, I'm sure this isn't going to solve that problem, but it could certainly help, right? If these companies are just hiding behind legalese and poor bidding mechanisms and lack of competition, as well as the information asymmetry with the governments who are paying the companies to deliver these projects, maybe it could help. And to Jay's point, you have to convert this into some type of, maybe you don't have to convert it into legalese, but someone has to convert it into legalese, right? How you would change the the bidding contracts for, different types of government projects.
Yeah, I mean,
Yeah.
more pictures and little, examples instead of, I mean, every one of the equations, change them into an example. Sort of like you were saying about the car, case, right? Adding a lot more examples, taking out the equation because nobody will understand, right? Take out all the equations, but give the examples of what it all could mean, and maybe start pushing it a bit. I think it may be important. It's I mean, these kind of this kind of research has a lot more relevance in terms of the economy. I mean, so much money rides on these things, right? And like Mike was saying, that's a stunningly bad result, right? I mean, if over the last 40 years, if the construction industry has become that bad, it just means we've just been doing things wrong.
And they don't have incentive to optimize.
Yeah, there was no mechanism to make them more efficient. That's only because these are private, construction companies, right? So if they are getting worse, it's because we are letting them, and there is no incentive for them to get better. Maybe these are all steps in the right direction to maybe start making them better.
Yeah, exactly.
Maybe a big NSF proposal for this.
Well, that's, I guess that's
Pablo
another
is
question.
thinking of that, I guess.
I was wondering if you had funding for this research.
For this?
Like any particular projects?
No, currently, not this. Pablo might write some proposal regarding this. I think he told me before, but not this moment. Yeah.
No, I was texting with my daughter. I mean, like I said, she's at Northwestern. So I was just saying that, just listening to Dr. Shu's talk, and then she was actually saying, yes, Pablo was talking a lot about his research. So I think he has been pushing. I mean, she's in her first year, right?
Yeah.
Anyway.
He's excited on that. Yeah. And also some takeaways from this research is also, so if you can take a look at this graph, and you see really if you have more bidders, so I mean, if you have more bidders, competition goes up, then this green line. So basically the green line is one of the current practice. Yep. So if the green line will increase, it will converge to the optimal. So basically you have a perfect competition. So people are always saying you have perfect competition. So firms are getting zero profit. So a lot of I read a lot of research articles on the franchise, including the Vilhoffs, and they are saying we have a case that we assume the firms are getting zero profit, but that's not always the case. So there's a big gap between the theoretical design and the reality. So if firms getting zero, they don't have incentive to come. They just because they can get a lot, so they won't come. And if they have a perfect competition, there's no need for this kind of information asymmetry setup. But just because the lack of a competition, and because of this lack of competition, they can hide their cost. They can lie about the cost, and there's no way the government will know it, and probably the government know it, but the government don't want to do with it. So
well, they don't know what to do with it. That's the thing. I mean, that's where the theory helps. They are beginning to probably know a lot, but they don't know what to do with that information, and a theory for that would actually help. I have another question, not connected to this. So do you use any of this at Google, or what kind of division of Google do you work at?
No. I kind of like doing separate work. So
totally different things at Google.
Okay. Yeah.
I mean, that may be of interest to our students to know.
Yeah. So, but I mean, if you work in industry, you really can't control things you want to work on. So, yeah. So that's why I really kind of like admire you guys, that you guys can just kind of pick up the topic you're interested in and work on it. Yeah.
Oh, could this be used to like identify non-competitive behavior, like even like implicit cartels between
Yeah.
between the firms?
That's a great case. Yeah, it can use to identify that. So the thing about it, so this is what we call actually we have to do a little bit adjustment on the because previously I assumed that everyone is independently identical and their goal function is separate. If we have some cocktail like we mentioned, this is called they could have force a collision. So and they force a collision, they will share the objective goal. So basically, they will kind of like they said, whoever get the franchise will take like 70%, and the rest will take 30%. This is we have some collision proof mechanism. So basically, we need to adjust, make some adjustment on that, and this. The demand purchase is also able to this demand purchase mechanism, as mentioned here, the orange one is also able to solve this problem. Why? Because the demand schedule is published by the government. Basically, there's nothing you can do. You can form a coalition, but you still need to do the competition. If there's one firm are bidding the demand higher than you, they will get it. So we still have the competition. And in the cocktail or some other case for the auction, they can talk with each other and to set, we have a tolerant capacity at this level, and we want to maximize our cost. So they want to kind of like say, we are bidding the same price. But in this case, it's different because your payment, all your payment is from the demand level you propose. And as I mentioned before, your demand price, your demand level is solved by you. You have an optimized demand level. It's not by others. You incorporate others' objective into it, you still get that optimal demand. So basically, the demand purchase is able to solve this problem. And it's kind of like you can do it online. So basically, the government can even publish this rule online, and everybody see it, can bid on it. The only thing they needed is the demand level. You can say the demand level. If you set the demand, if the government gave you the demand level and you didn't do it well, that's your cost.
Right.
Yeah. Well, so a dynamic version of this, with a period, every 3 months or every year. Is probably what would, I mean, a constant monitoring, mechanism. I think
you're making a great point. That's the extent. So this is the extension research I would like to propose. So I don't have a chance to kind of work on it recently, but it's one version of this is to make it dynamic. That's to say, this demand purchase is not paid in lump sum. It's paid in a quarter, like we just suggested.
Like a schedule,
like a schedule in a quarter, and the payment is determined by how the performance you get for this quarter. If you are passing a lot of traffic, you get more. If you are passing less, you get less.
Yeah.
So basically, I don't care about quality. I don't care about talk capacity. I just care about demand. If your quality is not good enough, you won't have that demand.
Yeah. But then there'll be all kinds of additional questions that will come up at that point, where if that demand is taken out from another facility, and now there is a freeway that's constructed here, another one that's constructed here, and then okay, you are taking the demand out from there, and that company okay, now it gets very, very complicated. The
we can analyze some network effect on that. It makes it complicated, but the main logic is like we have an invisible hand to check all the detailed production variables, and it all reflected in the demand. Yeah.
I mean, the other interesting thing is like the state of California wants to reduce one of their main performance metrics, right? Whereas your success measure for public welfare is demand or realized demand, right? Which means it's a very different perspective. Certainly you can argue that VMT isn't the metric that should be used, but rather something like emissions for emissions reduction, right? but it is interesting. Like when I read papers from, I would say like this version of literature, the fact that there is latent, or as our colleague Mike McNally calls it, suppressed demand out there, that when you add a new facility, that demand arises, is in one way, you know, a good thing. But for others who are interested in reducing VMT or emissions from vehicles, adding new capacity, new facilities, and that being heavily used is a bad thing.
Yeah, it's kind of like a market, so you need to consider the competition from this road with others. Yeah. So, but the government want to kind of like to maximize the overall market's surplus. So they are.
Well, I mean, the answer may be that you start with a whole network, multimodal planning, standpoint, and then you go down and first identify places where you really must construct, where demand must come out. I mean, if you are constructing, there better be demand, right? So the demand must get realized if you are constructing. So this idea that everybody, at least states like California, have, that we don't want to construct. I mean, they end up constructing in the end anyway, because the construction lobby will make them construct. But the party line is that we don't want to construct new facilities. I think that's somewhat regressive. I mean, there are things that we still need to construct. The problem is that you don't start with the decision that we must construct something. But we actually should find whether it is constructible, and if that is cost beneficial to do. And there may be things that need to get constructed. And in those places, we probably should use something like this. And the other construction may be high-speed rail. Maybe the same thing should be applied to high-speed rail, right? Which you can. I mean, there is nothing that highway specific in your basic ideas. So applying this to other modes also is very much possible, except the definitions of the total capacity that we started with would be different. It won't be the capacity flow multiplied by the toll, but it may be something else. But similar thing can be used in a multimodal type of a network. So yeah, there are a lot of potential for a lot of further work. Taking a more fundamental approach to things and just defining all the variables properly in terms of social welfare and public welfare that we were talking about. A lot of interesting aspects to the work. So yeah, just thoroughly enjoyed it. Thank you for spending your time and taking time off and joining us. Siva, all yours to wrap up.
Yeah,
we have a good time with you guys.
Yeah, thank you, Dr. Hangxu, and thanks for the questions from Professor J, Professor Hyland. Any questions from the audience? If not,
I gotta run. I'll talk to you guys later.
Yeah,
I also.
Yeah, if not, we will just thank Dr. Hangxu. Thank you for your great presentation.
You're welcome.
Thanks for your time.
Bye-bye.
Bye. Bye, guys. Bye, Dr. J. Bye, Dr. Hangxu.